Nginx is an open source web server written in C and can also be used as a reverse proxy and load balancer. In this video, I want to talk about the following. And as I start talking about this agenda, you guys are gonna start seeing some time codes where you can jump to the interesting part of the video that you actually want to watch. You don't have to watch the whole video, obviously. Yeah, so let's go ahead through and talk about this agenda. Okay, the first thing we're going to talk about is what is Nginx? What is this technology? Why did we build it? Okay, and then we got a little bit to talk about the things that kind of distinguish Nginx from other web servers and proxies. Now I'm going to talk about a use case where Nginx can fit in and very nicely the current and desired architecture within Nginx. Then we're going to talk about how Nginx can actually act both as a layer 4 and a layer 7 proxy, which is something I recently discovered. I thought it's a purely layer 7 proxy, but I was wrong. So we're going to talk about that. And then finally, the meat and potato, we're going to talk about example. We're going to install Nginx. We're going to show how it behaves as a web server. We're going to show how it behaves as a layer 7 reverse proxy. We're going to show how it behaves as a layer 4 reverse proxy. And we're going to also enable HTTPS, install a certificate from Let's Encrypt, enable TLS 1.3 because that's the latest and greatest. Because unfortunately, Nginx doesn't come with default TLS 1.3, which is kind of shame if you think about it, right? And HTTP 2, also, we're going to show how to do that, to enable that, because it's 2020, right? You shouldn't be using HTTP 1.1. If you can, enable HTTP 2. Minimize those number of connections. Enable streams and push and all that jazz, right? And finally, we're going to summarize the whole thing. If you're interested, stay tuned. If you're new here, welcome. My name is Hussein, and in this channel, we discuss all sorts of software engineering by example. So if you want to become a better software engineer, consider subscribing and hit that bell icon so you get notified every time I upload a new software engineering video. With that said, let's just jump into Nginx. All right, guys, so what is Nginx? Why did we build this thing? So it is one of the few software that actually act both as a web server and a proxy. And there are very few of those, right? HA proxy is not one of them. HA proxy just markets itself as a proxy, right? And there are like advantages over disadvantages, if you ask me, to play both roles, right? I kind of like the software that just does one thing really well. So yeah, so Nginx can be also a web server. And when you're a web server, you serve web content, right? And regardless what kind of web content, right, you can serve any kind of web content. That means you kind of need to know the MIME types. You kind of need to behave web servery. You're gonna patch any bugs that web servers have, right? You have to do web servery stuff, okay? So it acts like this one job, right? So if you have static content, which is a lot of people use that, right? So it's like static content, HTML, JavaScript, I want to serve it, Nginx can do that for you. Plus, it can act like a proxy. And we talked about what a proxy versus reverse proxy. If you want to know more about that, I'm going to reference the videos here. Actually, the playlist. So we went a lot of videos about proxies. And this is, you can take a career, just talk about proxies, guys. It's a very interesting topic. Very deep to me. I like it a lot. I like to talk about proxies because like, every day, talk about proxies and I have to find out something else, something new. Okay, so yeah, proxy can be a reverse proxy, which can optionally be a load balancer, and you can use it as a back-end routing if it's a reverse proxy. So you can, hey, if you're going to this application /app1, go to these set of servers because this app1 doesn't really consume much CPU. I dedicated some commodity servers for you, so go ahead there, and then 3 service instances is enough. Versus no, /app2 is actually a huge app that consumes a lot of resources and we need as much service as possible. So here's a pool of backend services of 20. So hit those instead. So you can do something clever like that, okay, with proxying. And you can do caching as well. So that's Nginx. So let's see what Nginx can benefit us from as a load balancer or as a proxy. So assume this is your current architecture. You have a database. Let's say this is Postgres, and it's listening on port 5432 because that's the default Postgres port. Okay, and you have, I don't know, one application, and that web server have like an endpoint, and you built like this exposed over HTTP, and you're listening to port 3001, and you give this address to people, and they start hitting your stuff. Says, hey, get/employee. So if someone consume that, obviously you're going to establish a TCP connection between that and your server, and you give them an ugly URL with a port in it. So who does that? And that employee's endpoint will communicate to the database at the back end. This could be using a pooling connection. This could be on demand, establishing TCP connection. Doesn't really matter, but you're doing this a lot, right? So another user can consume the employees. You hit the web server, and if you want to scale, you start thinking it's like, okay, I'm going to listen to another port 3002, but now you start sending people another URL. Say, hey, this URL is very busy. Use this instead, right? It's just silly, right? So what do? Here's how Nginx can help, or any load balancer for that matter. So you're gonna spin up as much of these servers as you want, right? This could be in the same machine. This could be Docker containers. This could be part of a Kubernetes pod. Who cares, right? It's just a bunch of IP addresses, right? Just listening to different ports. It could be the same port. Who cares? Okay. And this is all of them maybe hitting one database, or maybe you have a master follower kind of configuration. And then you put Nginx on top, and you made it secure, and you put certificate here, and listen 443, and there's TLS 1.3, and then you put HTTP 2, and everybody just communicate to the Nginx, right, server, and you can see what happened here. Let me repeat it again, right? So employees go here, you hit the server, and then Nginx makes the decision, oh, which server should I hit? Well, what algorithm did someone configure on me, right? Oh, configure load round robin. So I'm gonna hit this, and then the next request will go to the next server, right? And then that server hits the database, and the next request will go to the third server, and so on, right? And you might start saying, Hussein, why, if we're making requests to the same employee's endpoint, we can actually do caching here. We can put a varnish on top, like an HTTP accelerator that actually caches beautiful stuff, right? So we don't have to every time hit the database, this poor database, right? So minimize the number of queries as much as possible, right? So you can do all sorts of fancy stuff, right? So, but there is the idea. A single endpoint that people hit, right? And you make it, and you scale on the back end, right? So that's how Nginx can help. Anything in front of Nginx is called a front end. That's just some vocabulary for you guys. And anything behind it's called a backend. So if you heard me say backend and front end, I mean with regard to Nginx, right? Because this is a backend and this is a front end. But to this server, for example, the backend is the database, but the front end is what is Nginx, right? So that's what it means when they say like front end, backend. So if someone asks you what is a front end, backend, you have to know, it's like, what the hell are you talking about? Where are you first, right? Are you here? Are you here? Are you here? Well, there's no backend here, but maybe you can argue that the backend of the database is actually the disk, right? Or the storage engine, or S3 maybe. It depends where you store your stuff, right? Blob storage. All right, let's talk about the layer 4 versus layer 7 proxy. And I really recommend you guys watch the OSI model that I made to differentiate between these layers, right? The most interesting layers in software engineering, right? I know this is a networking stack, right? And we barely pay any attention to that stuff. But layer 4 and layer 7, if you want to understand, just know about these two things. Yeah. Layer 4, at that stage where TCP play, IP play, you have access to very few things to work with. You have access to the IP address and the port. And that's pretty much it. Maybe a few other stuff. Okay. Maybe the TLS handshake at that point. Okay. However, layer 7, you have way more stuff. This is an application. You have access, if this is HTTP protocol, you have access to the headers, you have access to the body, you know, it's a GET request or a POST request, right? If you're kind of watching at that layer, okay? And Nginx can play on both layers. And there are advantages or disadvantages that I'm not gonna go through in this video. I'm gonna reference the video, layer 7 versus layer 4, load balancing, Go watch that if you want a detailed 40 minutes details about what exactly the differences and advantages or disadvantages of what, right? Because we don't invent things for the sake of inventing things here in software engineering, right? There's always a reason, there's always a need, and then we invent things. And Nginx, you can do that. You can act like a layer 4 proxy, and you can act like a layer 7 proxy. And if you use the HTTP context, you can use the layer 7, the stream, that becomes layer 4. Cool. All right, time for an example, guys. All right, here's what I'm gonna do. I'm gonna go through the following. I'm gonna install Nginx. I have a Mac, so this is the tutorial will be on top of my Mac. But this is the only step that will differ for you. If you have Windows, find how you install Nginx for Windows. It could be as easy as just downloading a zip file and extracting it, right? Or it could be just as in Linux, could be as simple as just apt, if the Debian at least, apt get and install Nginx, right? So it's very easy to install. Once I'm gonna use brew for Mac. Once you install Nginx, I'm gonna show you the rest of the stuff, and everything here is exactly the same. Maybe here it's a little bit different how to use let's encrypt, but sure. Nginx, we're gonna show how Nginx has a web server. Again, you guys start seeing time codes because I'm very generous. I value your time, and I don't want you to watch through the whole thing to find the exact same thing that you want to see, right? So Nginx has a web server. We're gonna show how we spin up Nginx as a web server. That means we need some content to serve, right? Which we're gonna do. And then we're gonna show Nginx as a layer 7 proxy. Well, what we're gonna do is we're gonna spin up 4 Node.js services using Docker, because that's the easiest way to do that. And these are applications I've done before. I'm gonna reference the videos for. And it's just like they are ugly apps. They are a copy of each other, and we're gonna proxy Nginx through all of them. Okay. And then we're gonna show how to split the load, because now that we are layer 7, we actually can look at the URL and can make decisions based off that. So app 1 go to this set of servers, app 2 go to this set of servers. We're gonna block connections because we can do that, because we can look, right? We're gonna block admin connections, all that stuff. And then we're gonna show how Nginx can act like a layer 4 proxy, which is pretty cool as well. And we're gonna show also how to enable HTTPS on Nginx using Let's Encrypt. So we're gonna spin up a web server, listen on port 80, and then also listen on port 443. Generate a certificate for myself. I'm gonna expose my Mac to the public internet using some port forwarding on my router. I'm gonna forward port 80 and 443 to my Mac, so I don't pay anything. It's not on cloud. It's everything on my local machine, right? And then I'm gonna generate a free domain from newip.com, point that domain to my public IP address, and do all that jazz. Okay, we're gonna enable TLS 1.3 because it's not enabled by default, which is kind of shame, right? If you think about it, it should be enabled by default. Enable HTTP 2 on Nginx as well, because by default, the moment you do HTTPS, the easiest way is to enable HTTP 2. And the reason is because part of the TLS connection, there's this beautiful protocol, a TLS extension called ALPN, which is the Application Layer Protocol Negotiation. They can negotiate that you want HTTP during the handshake, which is awesome. Okay, let's just jump into it. All right, guys. So the first step, we can start with installing Nginx, right? All right. Let's go ahead and install Nginx, right, and see how to do that. Okay. To just do that on Mac, right? Make sure you have Homebrew, which is this brew thing, which will allow us to install pretty much a lot of stuff very easily. So I'm gonna go ahead and install Nginx like that. Brew and install Nginx. Okay, now once you do that, it will start downloading that package, installing and putting a configuration, right? A specific configuration where Nginx will be running. I'm not gonna use that configuration because I do not like use default stuff. If you know me from watching my 350 videos, okay? So here is the thing. So the default port has been set, says like, hey, this is your configuration, it tells you, and the default port has been set to 88 because you can run it without sudo, right? That's just all the default stuff. Here's what I'm gonna do. What I'm gonna do is like, I'm gonna delete that file. I'm gonna start from scratch, okay? So how about we do that? So we go to user, local, etc, Nginx, and then if you go to Nginx, if I do the Nginx.conf, you can see like a lot of stuff that we don't really care about, right? It's just, it will be very overwhelming for anyone to watch this and see like, what the heck and all that stuff, right? So we're gonna delete that file. You can make a backup if you want to, right? And then once you delete it, you can start writing one from scratch. So this is what we're gonna do, right? So we're gonna start writing one from scratch, okay? Nginx.conf. Let's go ahead and create a brand new one, okay? And here's the thing we want to do. First of all, we want to make my Nginx as a static web server. So how do I do an Nginx as a static web server? All right, so I am going to write the configuration necessary to make Nginx into a web server. So how do you do that? First, let's think about it. What is a web server? Well, web server needs a few things, right? A port to listen to, right? That's one, okay? It needs where to consume the static content, at least if it is a static web server, to serve these HTML files or JavaScript or CSS, right? So this is the minimum two things, right? And web server needs to be a HTTP web server. So you need to specify that you're working at the HTTP layer, okay? So here's the thing, let's do that. There is the context of Nginx is the HTTP layer, okay, which is the layer 7 here. I'm playing, all my config is within this, that's called directive. It's also called a context, okay? So if I am at this layer, I can create as many servers as I want, okay? A server that listens to port 8888, 777, 999, 80, 443, anything I want. I can do it right here. I can do SNI if I want to, server name indication, similarly, right? I can do so much stuff. So that's the first thing we need to do, okay? So let's go ahead and create one server here, okay? Inside that. So there's a block directive, and inside that block directive there's like the server that you created. Okay, so there's one server, and that server is listening on port 8080, sure, and that's called another directive. So this is called a block directive. This is called a block directive. That means it has other directives inside of it, and these are one of these things is called directives, right? And this is called a leaf directive. I just named it that because there's nothing inside it, okay? Just a normal directive. And if you do that just like that, that's enough to listen to a web server, okay? And for some stupid reason, Nginx forces you to use events directive, which is another context here, okay? And there's a bunch of cool stuff that you can have, like then minimum number of the worker connections, like because Nginx is a spin as processes, right? And how many connections can each worker process have, right? So I'm just gonna spin this up as an empty directive. You just do it this way, and Nginx will stop yelling at you. So let's go ahead and save that. Nothing much. So I opened a block, another block. I listened to port 8080. Let's see if this works. Saved it. Nginx.config is now saved. And now, if I do Nginx, just like that, it will start running an Nginx server, okay? And we'll look at the nginx.config file, which you wrote, essentially, okay? Sweet. Let's go ahead and see if this worked. So now if I go to localhost 8080, you can see that there is serve me default static file. Welcome to Nginx. I did not give it that file. Where did the heck did it pull it from? It pulled it from a default directory because guess what? You didn't tell me which path you want me to serve content from, right? That's why I made up my own. Okay, Nginx like that. It likes default stuff. That's why it's very easy to get started with Nginx because just there's so much default stuff. All right. Let's change that a little bit. What I want to do is I want to go through. Let's create a folder in my Hussein Nasser document folder, and let's create a folder called Nginx course. I don't know if this is a course. Let's do Nginx course, and then I'm gonna create. This is an empty file, right? I'm gonna create an index.html here, and then. Yeah, let's just do HTML, body, hello, it's Nginx, but it's my own content, okay? Some stuff, anything, right? And here's one index.html. Remember guys, this is the path now. Nginx, right? So let's go back to the config, which is user local etc nginx and the vim index.html. Here's what you want to do. We want to serve the content from that directly. How do you do that? There is another directive called root, and you can just literally specify the path, right? My root in this case is user Hussein Nasser Nginx course. That's it. We close it. Let's see if that actually worked. If I do Nginx, I'm gonna get an error. Why? Because Nginx is already running. You cannot rerun Nginx. So what you can do here is, I changed the config, but how can I tell Nginx to reread the config? Well, stop and start Nginx is a start, right? You can do that, right? So let's do that. Nginx.s/s, which means send a signal to the Nginx main process to stop, okay? And then rerun this. And you might say, Hussein, I don't want to stop the Nginx because people might be connecting. And there's another way to do that, which is another command, signal reload. We're going to go through that. But let's talk about the basics first, right? And now, if I go back and I do refresh, you can see that I am now served my own HTML page, which is the one we wrote. Isn't that amazing, guys? Okay, it's amazing. Wait. That approach works great if you have one directive and you don't want to do fancy stuff, right? It's like one web server, one folder with all the content, okay? But what if you want to be fancy? What if you want to serve specific path based on certain locations? So what does that mean, right? So let's say I want to create different folders, different websites, for example, right? And not necessarily different websites, different folders with different content, and the users visit slash site 1 goes to this content, site 2 goes to that content. So how about we do that, right? So let's go ahead and comment out that line, right? And then let's exit and go back to my folder, users, Hussein, Nginx course, and let's create some other folders here. Site 1, make that site 2, right? Site 1, I'm going to create an index.html file, and I'm literally gonna call it, this is site 1, right? Sweet. And I want to copy that thing to, hopefully I'm smart like that and I can do this. Can I do this? Ooh, man. I started to know Linux now. If you guys know me, probably I've been using Windows for the past 30 years of my life. I recently started using Linux very recently, so I'm trying to be better at Linux, so yell at me if you find me doing stupid things and I can do it better. All right, so now we have a site 2 and site 1, okay? Sweet. Let's go back to the config. What is it? User, local, etc, Nginx, right? And then vim nginx.com. And guys, just by adding these two folders, if you think about it, that should give us access to the underlying site 1 and site 2, because it's kind of a relative path, right? Because site 1 is under Nginx course, site 2 is also under Nginx site 2 is also under Nginx course, so you can just access it very easily, right? So let's go ahead and just show you that. Nginx.ish is reload. I mean, go ahead and reload my changes, please. All right. And then if I go here and I refresh, I'm gonna get the root, right? If I do slash site 1, I'm gonna get site 1, right? And if I'm gonna do site 2, I'm gonna get site 2, right? But what if I have a completely different folder? I want to completely different path, right? How do you do that? Yeah, that's a completely different path. Let's say images, right? You have a bunch of images, and these images are a completely different path, right? It's not really relative path, right? So let's go ahead and create something like that, right? How about where? CD users, Hussein Nasser, and let's make directory images, right? Make directory images if I can type, and then I don't know. We need to put some images here. All right, we have a Postgres picture here. I don't remember how it looks like, but let's just test it out, right? So it is under Hussein Nasser images, right? So if I go to my path, user local, Nginx, etc Nginx, and then vim Nginx.conf, here's what I want to do. I want the images directory to have like a special folder, completely different, right? So if I do, you can have a location block directive. And if that location goes under images, right? What you want to do is you want the root to be users Hussein Nasser /images, right? But you don't really want images, right? Because this is the root now, and this will add the images prefix on top of it. So that's just enough, just like that, right? So let's take a look and see if that actually works, right? And what I want to do, Nginx-s reload. And if I go back now and I say, all right, this stuff should still work, site 1 and site 2. But if someone dare to go to images, right, you're going to get forbidden, which is a different message. And that's the reason, because we try to serve you the directory, but someone decided not to serve you the whole directory of stuff. But if you know the image, which we do, postgres.ping, you will be served, sir. That's the video I made for Postgres and Docker. Yeah, completely different directory, yet Nginx managed to do its magic, okay? Cool stuff. Cool stuff. All right, let's do one more thing with web servers. All right, let's do one more thing with this web server thing. Two more things, actually. All right, so what I want to show you how to do regular expressions. And let's assume we want to do a contrived stuff, like, I don't know. If someone tries to go to the images, right, and they were trying to load specifically a JPEG picture or anything that has like a JPEG extension, I want them to get an error, right? They can load anything they want except JPEG for some reason. I don't know. Maybe they're too big and I don't want them to download my stuff, right? And to do that, you can do the same location thing, but you can add like a tilde, right? When you add a tilde, you can start doing a regular expression-y stuff, right? And regular expressions like, and dot means what? Means any character, right? That, and then you start typing your stuff, JPG, right? That means anything, like this could be, I don't know, right? It could be that this will match, right? This will match. This will not match. This will not match. It has to be at the end, right? So that's the idea, okay? And if you really want it to be at the end, you have to add like a $sign at the end, and then let's just do that, okay? And then here's what I want to do. If someone tried to download any JPEG picture, or maybe any picture at all, if you can add more if you want to, I want to return 403. That means I think it's forbidden, right? That's the HTTP code for forbidden. Let's go ahead and save and see if it works. Nginx-s reload. Let's test it out. You can download postgres.ping, but the postgres.jpg, you're gonna get forbidden, right? It actually doesn't exist, but even if it did, you're gonna get an error. Okay? So let's go ahead and prove that to you guys and put a picture that is actually JPEG, and you can never download it. So here's the thing. I have put a test.jpg picture here, and if I do test.jpg, I'm gonna get an error, right? Despite the picture being there. So let's go ahead and actually remove that condition and see if actually it works. So what I'm gonna do is, I don't know, let's just comment this line out, the whole thing, okay? The whole spiel. Comment it out, and then reload my configuration, go back, refresh, and you can see that I can load the picture. But the moment I remove that thing, I put it back in, nobody can download any JPEG. How amazing is this, right? Try to load it, get forbidden, because that's what we told it to get. We returned 403, which is the forbidden. And you can do all sorts of stuff. You can return all sorts of status code. And I can't possibly go through all of them, guys, okay, in this video. Sweet. We learn about regular expressions. You can use your regular expression skills to do fancy stuff. But let's do one more thing. I'm going to create another server here, guys. And that server, because you can create as many servers as you want, right? The first server listening to port what was 8080. This server is actually 8888, right? Listen, 8888. But if someone tries to go to location slash, which is the root, if someone visits this page on 8888, guess what I want to do? I want them to go to this web server. Well, Hussein, how do you do that? Well, very, very simple. You literally say proxy. If someone visits me as slash, that means like literally localhost colon 8888 slash, then take them to this site instead. So I'm going to proxy pass this, and that's a layer 7 proxying, to HTTP localhost 8080 slash. Just take them to that site, right? So now we just did aliasing, if you think about it, right? So now if I go to local 8080, that's my original website. But if I go 8888, you can see that we're also going to the site, right? So 8888 and 8080 is doing the same exact thing, right? So you can play with the proxy pass, and you can do so much stuff with this, guys, right? You can do to a completely other proxy. You can do, if this goes to this site, go to this, and if this goes to this, you can go to so many things, right? Like, let's say you want to do the images, right? How about images? If someone goes to location slash image, right? You want to take them to the images, right? Proxy pass, HTTP, localhost, 8080 slash images. You can do that. That's powerful. You know why? Because now slash image on this guy, postgres.png, will load me the picture. That's all. It's kind of shorter if you think about it. But that and this guy, and this guy, 8080, is exactly the same, right? So this proxies to this, right? And how it does this, it's a completely different topic, right? There's TCP connections on the backend, there's connections on the front end, and it was in Nginx. I noticed that it's always lazy load things, right? So whenever it's desired, whenever it's needed, it does it. Okay, HA proxy is the reverse. It loads as much stuff as possible, and so startup is like a little bit slower, right? But when you request it, it just immediately gives you the result. All right, that was the web server stuff. How about we play Nginx as a layer 7 proxy, guys, and we proxy it to four Node.js services. First of all, we need to start my 4 services, right? So how do we do that? Okay, so docker run -p. I'm gonna start 4 Node.js services, okay? And I'm not gonna go through how I did that. I'm gonna reference a video which goes into the details of how I created my application and dockerized it and made it into a container, right? But it's very simple. These applications are very simple applications that have a simple REST endpoint, right? So the first application is running on port 2222, mapping port 9999, and what I wanted to do is I want to assign an app ID for this so I can address them very easily, 2222, and then I want to detach it, and the app is called Node app. Spin up one, then we're gonna spin up another one on port 3333. We don't need names per se for this, but sure, you can do that if you want to. and then 4444. Cool. Ah, we messed up, guys. 4444 9999, and then finally 5555. So 4 applications, right? 4 Node.js applications, and we're gonna go through them now. Cool. Let's try them out. So we have application running on 2222333344445555. Let's test it out. Localhost 2222. This is the application. Literally, just when you go there, it says I am app 2222. Homepage says hello, right? And there is, if you go to /app1, there is an application 1. It says, hey, the application 1 says hello. And the reason I'm doing that is just because I wanted proxy and show you what application is actually being served now, okay? Application 2, and it says literally application 2, and the final application is admin, okay? And this is the admin page. I want admin page to have fewer customers as possible, right? Very few people should see this page, okay? And exactly 3333 is exactly the same thing, okay? And 444 is exactly the same thing as well, right? You get the idea, okay? Up until 5555. So we have 4 applications. Cool? You get that so far, right? Here's what I want to do. I want my Nginx to listen on port 80, not 8080, okay? Right? And I want to proxy load balance these 4 applications, okay? So every time I visit localhost 80, which is just like that, I want it to go to 5555, then 2222, 3344, and then I want to round robin through them, okay? So that's what we're gonna do now. So let's go back, clear, Nginx config, and how about we do the whole thing again, because it's always good to redo things again. I'm gonna delete it. So before we go then, I'm gonna make a copy of this Nginx file because I'm gonna have a GitHub where you can check that stuff, right? So I'm gonna make a nginx.copy into webserver.config, okay? So guys, you can play with that and see what I did here, okay? So that's my web server, okay? That's how I do web server and all that jazz, all the examples. But I'm gonna remove this now, the nginx.web.config, and I'm gonna create a brand new one because it's always better to start from scratch, right? So same thing, very, very similar. You create an HTTP because you're playing on what layer, guys? On layer 7. When we want to use the HTTP protocol. And events, because Nginx is stupid for some reason, it requires me to have this. It should be optional, but I have no idea why, right? Maybe it wants people to pay attention to these configurations, the worker connections and all that stuff, but I still don't understand why. I think it's just a bug, in my opinion. And yeah, HTTP, what do we want? What do exactly we want? We want, guys, if someone goes to this page, I want to proxy it to the backend, right? Which are what applications we have application running on 2222, 33, and 44, and 7, and 55, right? So how do we do that? It is incredibly simple, okay? You create, first of all, let's listen this time on port 80. So we kind of need to run Nginx as root here, sudo, right? Because these ports are kind of system reserved. So you need to run that. So if I do that, and if I do location, first of all, we forgot. Okay, see, guys, it's just always, you have to do so much times until you understand it. So we need a server. We forgot to create a server, right? I'm going to create a server, and the server here, listening on port 80, okay? And if someone tried to go to location /, I want them to immediately proxy pass, like we learned in the web server, but I wanted to proxy pass to a special backend that it doesn't exist yet. And I'm gonna call it all backend, right? There's nothing called all backend here, right? That's it. That's what I'm gonna do, right? So all backend here is something that is completely bogus, right? But guess what? It's no longer bogus if you actually create it down here, okay? All right, so How about we create a backend, right? And that's very simple to create here in Nginx. Really, it's called upstream. I'm gonna create an upstream backend called all backend, right? And this backend have a name called all backend that I just named here. And here's what will happen. If you go to / on port 80, it will proxy pass it to this. And here's where the magic happen, right? This backend doesn't have any backends right now. So how do I add? You basically use the server directive. And this time, this is not a block directive. It's just the terminal leaf directive, right? And on port 127.0.0.1, on port 2222, that's the first server. The second one, you guessed it, 333, server 127.0.0.0.1, 4444, and then finally 5555. Get it, guys? So what will happen here? By default, when you create an upstream backend, there is a load balancing algorithm that is assigned by default, and it's called round robin. Round robin is like 1, 2, 3, 4, 1, 2, 3, 4, hot 2, 3, 4, hot 2, 3, 4. It will just go through them one by one. Okay. If you make a request, we'll take it. This is one. If you another request goes to this, a third request goes to this, and fourth request goes to this. That's called round robin. And you can do another. We're going to show another algorithm called IP hash and least connection, where you can do a sticky session if you want to, right? Let's do this, right? Quit. Nginx-s reload. And what will happen now, guys? First of all, I think we didn't. Let's see if this actually worked. We might actually get yelled at. How about that? Actually worked. I didn't have to do sudo. I think because I am already an admin. Okay. Now if I go to localhost, I want you to pay attention to what happens here, guys. Refresh. See? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. That's round robin. Okay. Every request will take me to the next one. Okay. And if you're interested in what exactly is happening, I am a browser. And I have established one TCP connection with Nginx, right? In this case. And I am one TCP connection away from the Nginx as a browser, because one is enough now. And Nginx on the backend has established 4 TCP connections with the 4 backends, okay? So I am terminating my connection at Nginx, because it's a layer 7, right? I'm playing with the layer 7. So I'm sending an Nginx request. Hey, localhost / it takes the request and says, oh, localhost / means proxy pass to one of the backend, all backend, which I mean, I have to go through one of them one by one. So it's like, okay, I'm going to send it to this request, right? This is the TCP connection I'm going to use. This is the TCP connection I'm going to use, and so on. Cool. That's exactly what's happened. That's why you're saying it this way, right? Cool. And you can see, I want to use another IP algorithm to show you. If you go here and you can add an load balancing algorithm. One of the load balancing algorithms is called IP_hash. I'm not going to go through all of them, but IP hash is one of them, and what's the popular. And what it does, it says, hey, it takes the IP address of the client and hash it into this algorithm called consistent hashing, and finds out one of these 4 server and stick to it. That means all requests coming from this client IP address will always go to one and only one backend. And people, for some reason, love this, especially for stateful connections. Okay, they love this sticky session thing where, hey, if stateful applications, well, if you don't know what stateful versus stateless application, I made a video, go watch it. But stateful application is generally a bad idea, right? Because you're storing state in the memory, and what you do essentially is you're relying on that state to be there on the next request, right? And There are good reasons to do that, but generally we're moving way more into a stateless architecture where you can get destroyed at any second, especially in a Kubernetes cluster, right? You can get destroyed any second. Your container, your application can die. You cannot rely on anything. So the idea of having a state that is sticky in memory is less and less desirable. But I'm not here to judge, okay? There might be good use cases. That's why this algorithm exists. Otherwise, it won't exist, right? Nginx, that is reload. If I do that and refresh, no matter how many times I refresh, I'm gonna be sticking to the server 2222. That's it. /app1, same thing. I'm going to /app1. /admin, 2222. That's it. The TCP connection is established. I have one client IP address and my algorithm is always IP hash. So I'm stuck to that. Okay. So that's essentially this. But I like my round robin because my applications are stateless and I don't care which backend to hit. Coolish, guys. Coolish. All right. How about we do some fancy stuff? I'm going to create, let's assume my application one, app one, is heavy stuff, right? And I want, for example, to assign 3 servers for it, okay? Or 2 servers. Like I want to assign 2 servers for application 1, 2 servers for application 2, right? I don't want to split the load, right? Because application 2 maybe, I don't know, maybe it's another application and I want just to assign 2 or maybe 5 or 7 instances and I want them to go to this. Application 1, I want it to go to different backends, right? So you can create as many backends you want. So I'm going to go ahead and create upstream, if I can spell, app1 backend. And I'm going to create another upstream backend, app2 backend. By the way, it doesn't have to be lowercase, right? You can be fancy if you want to. And you can just do 127.0.0.1. App 1 is essentially 2222 and 3333, right? And app 2 is 4444. And then 127.0.0.1 is 5. Okay. So what now? What the heck does that mean? Now we have backends, but we didn't really flip things together, right? So how do we do this rerouting and that we talked about? And I can only do this because we're a layer 7 proxy. I want you to pay attention to that. All because of this. Wait a second, sorry. All because of this, HTTP. Because I'm using an HTTP, I'm playing at the HTTP layer, which is a layer 7 layer, I can do all that fancy stuff. Otherwise, you can never do this, right? So I want to do location. If someone goes to app 1, I want to proxy pass it to which upstream service? App 1 backend. And if someone goes to boop location app 2, I want them to proxy pass it to HTTP app 2 backend. See if we get this right. I'm not sure if I have to add a slash at the end of this or not. And I'm not sure I have to add app 1 here. So let's see if that worked. Yeah, I think it will work. Refresh. And now if I go here, slash, I'm still round robining, right? Because we removed that IP hash algorithm. I'm going through all of them because slash, but going slash app 1, enter, I'm round robining through only 22 and 33. Sweet. And if I go through app 2, I'm round robining from 44 and 55. Isn't that sweet, guys? And you can use like a load balancing algorithm different in app 2 versus app 1. How cool is this? And you can do all of that stuff, by the way. So coolish. Let's do one more thing. I want to block admin connections. Anyone that tries to get to the admin interface from outside the internet, like on port 80, don't let them in, because now they can, right? They can just type admin, and admin essentially is just round robining because it doesn't know what to do, right? You didn't tell us what to do, so it's gonna do all of it, right? I'm gonna block this. I don't want to access admin from the port 80. I want it only if people knows this. Because like the internal backend, if they have access to the internal backends, I know it says all localhost, but think about these ports 2224443. They are internal network that nobody have access to. Okay, but you just expose the admin API. We don't want to expose the admin API to the public internet. What do? Well, Nginx to the rescue. If someone tries to do admin, then literally return 403. That means forbidden, babe. You're forbidden from going to the admin API. So now you can access it from 2222. Sure, you can access from 3333. But if you go localhost admin, sorry, babe. Nope, you're not coming. I'm sorry, you cannot access it, right? Because we're cool. App 1, we still round robining, right? So that's how you block things if you want to block things, right? Isn't that amazing, guys? All right. This has been the layer 7 stuff, right? As usual, I'm in Nginx.conf as http.conf, and this is my layer 7 tutorial. Let's do a layer 4 tutorial, okay? I'm not gonna delete a lot of stuff here, so I'm gonna just go ahead and delete this. I cannot do any of that stuff in layer 4, so I'm gonna delete that. I am going to delete this, delete this, delete this, and delete this, and delete this, and delete this. DD, by the way, deletes in Vim if you're interested. All right. Let's see if this works now. I'm still a layer 7 proxy, but I just want to make sure that I didn't break anything. All right. Slash. All right. So we're round robining, right? And here's the thing, guys. I want to act as a pure layer 4 load balancer. What does that mean? That means, and let's talk about this a little bit. In the layer 7 load balancer, the browser communicates with the Nginx, right? And that's one TCP connection. It can increase, obviously, guys, because we're using HTTP 1.1, so the browser can open up to 6 connection. That will change when we implement HTTP 2.0, right? Because it was only 1, and you can multiplex stuff. But, right, so one TCP connection, let's assume simplicity, one TCP connection between the client, the browser, and the Nginx. And there are 4 other on the back end, okay? Because between us and the Nginx, at least 4, because I don't know how Nginx works. I never read the source code, so it might open 4 or more, but at least it needs 4, right? Between Nginx and each of these guys, right? And it will have these stateful connections running. So we have 5 in total connections, and you can control these maximum number of connections. 5 connections, and if you have more, then it's gonna start increasing as well, right? Here is the thing. If I want to use a layer 4 load balancer or layer 4 proxying, then what will happen is the proxy will just stream the connection back to the back end directly. So the browser will essentially connect to the proxy, but it will not terminate the connection immediately. It will just have a NAT table, that's one implementation at least, and we'll say, hey, okay, you the IP address this, the client, going to this backend, I want you to take to this backend. It will pick one backend and will just, that's it. It will establish the TCP connection on the backend. And it will just map the IP addresses. Okay, this IP address on this port going to this IP address on that port. And it will just map the TCP connection to the backend. So it's technically, it's one TCP connection to the backend. So let's show you that, okay? And how do you do that? So simple. You change HTTP to stream. That's it. I don't know why why didn't it call it TCP? That would be much easier. But the moment you call it stream, the whole thing now is a layer 4 proxy. That means you cannot use location because guess what? You cannot really read anything. In fact, even this will fail, as we will show in a minute, because location slash is like, sorry, man, I cannot do location because it doesn't make any sense. And let's actually prove it. If I do that, okay, and I do Nginx-s reload. See? Location directive is not allowed here. It says, what the hell is location? Sorry, you're a layer 4 load balancer. You're a layer 4 proxy. I cannot read anything. There is no slash anything. There is no HTTP anything, right? All you can do is, guess what? It's all or nothing. Oh, okay. I deleted that accident. It's all or nothing, right? So if you're listening to proxy, just proxy pass, and that's it. You can't even tell me HTTP, right? Just tell me which backend you want to stream to. That's it. I want to stream back to the backend, all backend. You cannot say HTTP. You don't get a choice. I do not know what protocol are you using, which could be a good thing, right? If you're proxying as a layer 4 proxy, any protocol at the layer 7 will work. WebSockets, SMTP, right? The WebRTC, anything, right? Anything, HTTP, anything will work because I just deal with TCP packets and I just will magically forward stuff to this. And I'm gonna still use the round robin algorithm here, guys. But you're gonna start noticing some weird thing. And we're gonna explain it in a minute. So let's go ahead and save this. And if I do reload, now I'm not getting yelled at. Let's test this out. All right, so let's close again and do it all over again, okay? It's just to clear any more cache if there's any. I'm gonna go to localhost / I'm gonna hit enter. Hit 2222. Refresh again, still 2222. Refresh again, still 2222. What the heck is going on? I thought I'm using round robin. Hussein, you told us this is round robin. This round robin algorithm sucks. No. Nginx is doing exactly what you asked it to do. Remember, you are a layer 4 proxy. That means the browser, what is it doing? The browser establishing a TCP connection between the browser and Nginx on port 80. So it did that. Nginx said, wait a second, I'm a layer 4 proxy. And all right, so I'm supposed to forward this connection request to a backend. I have 4. Which one should I choose? Well, this is round robin. Let's pick one. I picked 2222. So I'm gonna communicate the connection all the way to the backend. So now I establish a TCP connection with that backend. The Nginx engine does a NAT, network address translation. That's one implementation at least, right? I don't know what's the internal implementation, but what it does is like, hey, this IP on this internal port is trying to go to me, but the real me is one of those backends. So I'm gonna add an entry says, okay, you have to go to port 2222 on this public IP address, on this IP address, which is one of that. And I'm gonna add this. And guess what? Any future request on this TCP connections from this request, from this IP, is gonna go to 222. Because what? Because it's one TCP connection, guys. It's one end to end. So if you now refresh, you're not gonna establish a TCP connection again. You're just gonna use it to send content in it. And get slash is one of the content. If you do slash, right? And we're gonna see some stuff changing, and we're gonna explain what's happening here. But most of the time, if you refresh, right, you're sending content in the same TCP connection. The browser sometimes, because it's HTTP 1.1, it establishes 6 TCP connection. And if you're lucky, it might hit another TCP connection, which will hit another server on the back end, okay? That will become very clear once you use Telnet, for example. Let's go ahead and do that, actually. So yeah, for Airfresh, I had another TCP connection. The browser, you cannot control that, right? Because the browser, if you're using one TCP connection, it's gonna keep using it until it decides, okay, I want to use another one. If you're refreshing too fast or you're making a lot of requests, is gonna make a request to use another TCP connection to make that request, and that TCP connection will hit another server. So you can see, like, sometimes I go to 222, 333, 444. It's not very clear here. Okay, let's go ahead and telnet and see how actually this works. If I do telnet and I do 127.0.0.1 on port 80, you can see I do a GET request and I was served from 5555, right? I'm a layer 4 proxy, but I've been served from this TCP connection and the connection has been closed immediately. So if I do it again, this is 2222, right? Do it again, 3333. Do it again, 4444. That does look like a round robin to me, right? It is a round robin, but at the layer 4 level, okay? Hope that is clear. But it is very, very powerful to proxy things, data as they exist without actually looking at anything. And you can do certain things here. You can look at the IP address, you can block things if you want to, and do so much cool stuff. All right, time to get serious. Time to get serious. I want to flip back this connection. Let us copy this Nginx as a tcp.conf, and then I'm gonna bring my configuration, my HTTP layer 7 configuration back, because guess what I want to do? This is my layer 7. Sweet. Let's make sure it works. Nginx-s to reload. Let's make sure it works. Works. Nice. Next thing, I want to go to my router and I want to add 2 rules, port 80 and port 443. And I want that to point to my public IP address so I can create a domain, so I can make this a public address. I want to host Nginx to the public now. I want make a domain and I want to enable HTTPS and I want to enable a certificate and TLS 1.3 and all that jazz. So the first step is to make my website public. How do I do that? I have localhost, but if I do public IP address and I take my public IP address, right, and I do HTTP, it's gonna fail because, well, you're trying to connect to my public IP address, which is my router, and my router is not listening on port 80, at least in the public side, or 443, so it's gonna fail, right? So what I'm gonna do is I'm gonna go to my port router here. All right, guys, so here I am in my router and I want to add 2 port rules. I want to forward port 80 for HTTP and I want to forward 443 for HTTPS. So to do that, I'm gonna create an application called HTTP, and anything that is from 80 to 80, go ahead and forward it to this machine, which is Hussein Mac, all right? So it's very simple, right? So to the port 80, right? I'm gonna add that. I'm gonna add a very similar rule for HTTPS, which is 443, 443, 443, and then add. The moment I do that, now I have 2 rules. This guy and this guy is pointing to my router, and my router will do a nice port forwarding, will forward any packet that goes to 80. That's kind of dangerous, guys. You don't want to do that, right? But I'm just demonstrating things, but it's gonna forward. If you know what you're doing, then by all means, right? I'm gonna forward anything that goes to my public IP address to my internal MacBook, which is listening on port 80, right? Which is what we did, right? Is this still running? Yes, it's running, okay? So now, technically, if I take my public IP address and hit enter, you can see that it's working. And that's the state you wanna reach here, okay? Public IP address working. If I give you this public IP address, you'll hit this. I'm gonna remove it after this video, but sure, okay? That's what we wanna reach. The next step is, I wanna go to noip.com. So essentially what you need to do is create a new host name using this service that points to your public IP address. And it's a free service, so you're gonna get an ugly domain, but who cares, right? So I'm gonna go ahead and create, I don't know, let's use nginx test.dns.net. nginx test.dns.net is actually working. Okay, so this points to my public IP, which is this guy, which we know it works, right? If I paste it here, that works, right? So how about this guy? Now, in few minutes, this should work. This should just point to my public IP address and should update the DNS entries, and everybody in the internet should get this ID. All right, guys, took a while, but now my public DNS website is rocked and loaded. All right, so now this website is now public, right? And that's the step we want to reach so we can enable HTTP. So now I have an HTTP. Obviously, I'm going to prove that this is just HTTP 1.1 because, well, that's because HTTP 2 doesn't work with unsecure stuff, right? So you see, it's 1.1. It does work with secure. It does HTTP 2. You can do HTTP 2 and on unencrypted, but most browsers don't support it because it's very hard to upgrade the connection, right? Without TLS, right? Because we're using ALPN essentially to negotiate the new protocol, right? So that's why browser says, you know what, only secure. And I love this about it. This is a great decision. All right. What's next? Next is we want to use Let's Encrypt Certificate Authority to get a certificate for my beautiful shady website. How do we do that? Well, we go ahead and install Let's Encrypt. On my Mac, we're gonna install Let's Encrypt. On your Linux, I'm gonna reference the necessary stuff you need. You need essentially the certbot API, essentially that allows you to generate this stuff. The public key and the private key, essentially, that will identify your certificate if you think about it. All right, so go ahead and install Let's Encrypt. Brew install Let's Encrypt. That will give us the certbot API. Okay, that's it. Install the jazz. Beautiful. It's using Python. Sure. Okay. Once you install Let's Encrypt, I'm gonna reference the site below for if you're using Windows or other stuff, but it's very similar, guys. It's just once you know it, we're gonna use, we're gonna ask Let's Encrypt for a certificate, and to do that, okay, and it's already right. To do that, first of all, we need to stop Nginx, right? So we're gonna do clear Nginx-s stop, please, because the bot we're gonna run is called certbot. It's gonna listen to port 80 on itself, and it's gonna communicate with Let's Encrypt, and they're gonna negotiate a certificate, and they're gonna send us the beautiful public key and private key and securely, right? And we're gonna have the public key and the private key. We're gonna tell Nginx about our public key and private key, right? The public key essentially is part of the certificate, right? And the private key is also the thing that the server will use to essentially decrypt the traffic. Let's go ahead and do that. Okay, so how do you do that? We have to use sudo because it's listening on port 80. So sudo certbot cert only, right? I want to use the same exact thing I did with HA proxy. That means I'm not gonna do fancy stuff for certbot for Nginx. I don't want this thing to touch my config. I want my config to be touched only by moi, okay? So I'm gonna generate a standalone certificate, essentially. I think it's called dash standalone. So sudo certbot cert only dash standalone. And when I do that, it's gonna ask me a few questions. I say, hey, what's your domain? What's your name? All that jazz. And it's gonna communicate with the Let's Encrypt community website to generate the certificate and then download it and then write to disk. And again, I'm gonna use the public key and private key to add it to my config. I do not want this thing to touch my config. I know there is another way that it actually goes and touches my Nginx config. I don't like that. I like to understand what's going on. Let's go ahead. To my password. Enter. It does its thing, listening to port 80. And it's asking me for what? For what's my domain? It's called Nginx test.ddns.net. I think so, right? Shady website. Obtaining a new certificate. Listening to port 80. All that stuff. And just like that, we have the public key, the full chain with the certificate, and we have the private key. And these are the two things we need exactly, okay? So I'm gonna copy this guy, and let's remember their location, guys, right? So this guy and this guy, okay? This is the public key. Let's go to my config. Let's copy this first because we're gonna need it. Okay, the public key and the private key. We'll come to that, okay? I want to go to the same server here, and I'm gonna listen to an additional web server. What is it, guys? What is the HTTP listening to by default? 443. And we want to enable TLS, so we have to add SSL, right? It's just legacy stuff. That's why it's still called SSL from the old stuff. And then when we listen to 443 and we enable SSL, the Nginx will require two things. It will require the public key and the private key. The public key is SSL_certificate, and then you just paste that public key, the full chain, right? And then I'm gonna save and exit so I can copy the private key and come back, okay? The private key, Nginx config, and then we go down, and then we're gonna add the SSL _certificate _ private key, and then paste. I'm not expecting you to memorize all this. I definitely don't, but I try to make sense of everything that I see, right? That's why you just need to understand every single line. That's why I don't like to use default configuration at all. I need to understand what the heck is everything, okay? So now we're listening on port 443, we're SSL, we're secure, we're all that jazz. And now, if I save this stuff, we have the public key, we have the private key. How about we run Nginx? Well, there's nothing to reload, so we have to do Nginx run. And we're getting a permission error. And this means that it's time for us to run Nginx as root, which I don't like, but we have to do it at some point because we're reading through this directory, and this directory is only sudo people can access it. I mean, you can copy it to another directory if you want. You can create another user. There are a lot of stuff. This is not production ready, guys, right? I'm not giving you production ready stuff, but you have to understand what you're doing, essentially. There's always a best practices to do anything in life. All right, we have Nginx running. It's listening to port 80, listening to port 443. It has a certificate. Let's test this thing. Refresh. That's the insecure part. But if I do HTTPS, enter, we are secure, babes. Look at that. Connection is secure. This is legit website right there. And it's by Let's Encrypt. And it is Nginx test. Look at that. Let's Encrypt. Beautiful stuff. You can change the ciphers, the default ciphers. This is a very bad cipher, by the way, RSA encryption. Very bad. I say very bad. Like it can be broken with a shady laptop. No, right? But it's not perfectly forward. Okay, that's what I meant, right? So there's so much stuff better. Diffie-Hellman, you can force Diffie-Hellman. This is definitely not a TLS 1.3. I cannot tell how you can know if a TLS site is using TLS 1.3 versus 2, but just by looking at the certificate. But there are websites like TLS Checker. So this website allows you to check if your website is running on the latest and greatest. If I paste this guy and run, it's gonna yell at me. It says, hey, by the way, your configuration, your web server is not running as the latest and greatest TLS 1.3. It's using TLS 1.2. See, it says moderate, unfortunately, right? So if I look, it says, hey, it doesn't have TLS 1.3. It's not enabled, which is bad, right? So next thing we're going to do is we're going to show you guys how to enable TLS 1.3. Sadly enough, guys, if you go to the official nginx.org, right? That's the website, right? The official Nginx. They also are not using the latest TLS 1.3, which is weird, right? It's kind of embarrassing if you think about it. This Nginx, the holy grail, right, is not using the latest TLS 1.3. And I don't know why, guys. It's beyond me, right? So let's go and enable TLS 1.3, guys. Let's show you how you do that. So we'll go back to my config, and it's really simple stuff, right? So part of this, you can add another configuration here. And I think it's called SSL protocols. I might be wrong. Yes, TLS v1.3. You add it like that, okay? This way, I only want TLS 1.3. And if there is a shady client that wants to communicate 1.2, I want to error. I don't want this client touching my web server to begin with, to be honest. If there's like Internet Explorer 6 trying to connect to me, right? I'd rather this guy doesn't consume my stuff and fail, right? But that's just me, right? People always support backward compatibility, but if you want to be secure, more secure, and if you want me, you see me make a big deal between TLS 1.3 and 1.2, guys, this is really serious stuff. 1.2 first, it's so slow, right? Because it has 2 round trips instead of 1. Second, it uses very ancient ciphers, right? By default, right? So that is another bad problem, right? So by default, it can easily susceptible to downgrade attacks. And if you're running production stuff, right, you cannot afford that stuff, right? So TLS 1.3, I made a video about TLS. Go watch that if you want to know more details. But Diffie-Hellman, ephemeral Diffie-Hellman, perfectly forward, all that jazz, latest and greatest encryption algorithms, right? And I can specify the ciphers here, but I'm not gonna because this video is gonna get too long, right? So I'm gonna go just and use TLS 1.3 and let's save. And let's do sudo nginx -s reload. Obviously I have to do sudo now every time. Let's do that. Every time I have to do sudo now. All right, so where's my site? Refresh. Obviously you don't see any difference, but now we're using TLS 1.3. All right, so now we're using TLS 1.3. We're forcing people to connect with us on TLS 1.3. Final thing I want to do is this, guys. If I go to now side, I am now secure, but my protocol is 1.1. Not coolish, because now the browser, as we discussed, is going to create 60 connections, and it's going to do these stupid pipelining things and all that unnecessary stuff. So how do I use the beautiful latest and greatest HTTP 2 or maybe HTTP 3 in the future? It is extremely simple, right? Let's go to the config, go back, and you see this SSL? Just after the 443, SSL space HTTP 2. That's it. You tell it, hey, I want HTTP 2. And then you do, okay. And then you do save, quit. And then you do sudo nginx-s reload. Let's try it out. So now if I refresh, hopefully this will close the TCP connection and reestablish a brand new one. Oh. Okay. What is that? It is H2. Beautiful, beautiful H2. All right, guys. Not only H2, we're now TLS 1.32. Beautiful. See, I disabled TLS 1.2. That's the most secure stuff. That's how you want to do it. Nothing. I don't want to support anything older than TLS 1.3. That's a little bit harsh if you think about it, right? For a shady website like mine. But you can do it if you want to. You can specify configurations. I'm not going to go through it, but go to the doc, right? And read it to understand if you want to do like specific ciphers. Because my cipher are still bad. They're not perfectly forward per se, right? Because now If I look at my cipher, I think it's still using RSA, right? See, I'm still using RSA encryption. No. If you want to use Diffie-Hellman, you might specify also Diffie-Hellman. That's why I like HA proxy more, to be honest. I don't like these default things that are just old stuff, right? HA proxy forces you to always go forward by default, and it always using the latest and greatest security stuff, right? What version of Nginx anyway? Because people might start yelling at me. It says, hey, you might be using an old version of Nginx. This is the Nginx I'm using, 1.17. I think it's almost the latest, right? 1.17. As of 1.17, the default is TLS 1.2, right? And the default ciphers are essentially RSA, not Diffie-Hellman. All right, guys. Man, I think we did all what we needed to do, guys. Let's go back to the slides and summarize this. All right, guys. All right. Finally, we made it. You made it. You made it, guys. You made it. So, what did we discuss in this course? We talked about what is Nginx, this beautiful web server that acts also as a proxy, right? It does two jobs, and my personal humble opinion is if you're a software, you probably should do one thing and do it really well. You start doing too many things, I don't know how I look at you, man. It's just like, yeah, what are you? What is your identity? Are you a web server or are you a proxy? Okay, especially in this age where proxies are better, they matter more and more, right? Especially with service meshes and all that stuff. That's just proxy. Now, like for example, Envoy is just a proxy. HA proxy is just a proxy. Nginx, well, I'm a web server and also proxy. Well, Caddy, I'm a web server and also proxy. I don't know, but that could be just me, right? You might throw shade at me. Go ahead, but I like the software. If it does one thing, it does one thing and do it well. Because the moment you introduce more features, then you have more bugs, right? And the more bugs you have, the more vulnerabilities you can have. And that could be dangerous. All right. We talked about an example of current versus desired architecture, right? We talked about how Nginx, which is very powerful, supports layer 7 and layer 4, something I didn't know it had. I was really surprised when I saw that. So kudos to the Nginx team for that. Obviously, there is a paid version of Nginx, guys, which would have way more stuff, like, yeah. So things like we didn't even discuss, like OCSF and then SNI stuff, and I think encrypted SNI is gonna come soon, sometime when it's approved, obviously. But yeah, people are playing with that stuff now. Yeah, so we also went through an example. Right? We made Nginx as a web server. We made it as a layer 7 proxy. We made it as a layer 4 proxy. You can use WebSockets with layer 4 proxies with absolute simplicity, guys. So simple, right? I'm probably gonna do a video. Right? We enabled HTTPS. Kind of unfortunate that the defaults are so bad in Nginx, like TLS 1.2 and HTTP 1, and the ciphers are very weak. The default ciphers are weak, right? So all that stuff is a red flag to me. I just don't like it. Okay, if you're in a software like production software, you should use the latest and greatest, right, all the time. Okay, and finally we summarize the whole thing, guys. If I'm gonna pick a favorite, I'm still between HA proxy and Nginx. I'll pick HA proxy over Nginx, to be honest. I don't know. I just like the control I have over HA proxy, because it says, hey, you don't go to one file and edit that. I do not like that. HA proxy gives you the, hey, you want to run me? Tell me what configuration should I use? -f this config, use this config, or use this config, right? This is so flexible. There might be a way in Nginx, but I couldn't find it. Okay, because the doc sucks, blows chunks in Nginx, to be honest, guys. Is so bad, right? I didn't even talk about timeouts here in this video because it's so confusing, right? And I don't know if this wasn't on purpose, right? It was so bad on purpose, or was just literally nobody paid any attention to this thing, because the doc for a popular web server like Nginx, it is so bad. It's so bad. Weak, sparse. You cannot find anything you want. You would think that everybody will solve everything with Nginx, but no. The doc is so bad. HA proxy is way better for that, right? There's something that I don't understand about Nginx, to be honest, guys. And I know very little, to be honest, so I'm not gonna speculate more, but what I'm gonna say is the doc is weak for Nginx, right? HA proxy, the richness of the doc, and people writing blogs about that, just detailed stuff about every technology in HA proxy. I don't see the same thing in Nginx, right? So there are so many question marks for this technology, and I don't know. I'm worried. So, all right, guys, enough for me babbling. Hope you enjoyed this content. Gonna see you on the next one. What should I make next? Tell me in the comment below. I'm gonna see you in the next one. You guys stay awesome. What is going on, guys? My name is Hussein, and in this video I want to discuss the 6 timeouts that you can configure on Nginx to give you more performance, to reduce the latency, and to know what you're doing really when you see these timeouts. Because let's be honest, if you ever read the Nginx doc, it really sucks. Everything is one sentence for them. They don't go into deep discussion. They don't write blogs. They don't go into details of what their technology does, right? That's why it's always... Anyway, that's another topic for another day. Compared to other proxies such as HA proxy or Terrific or even Caddy. It's not really a proxy, but yeah, so they write good doc, and where the doc falls short, actually they write blogs, right, to accommodate that. Anyway, right, so in this video, guys, I'm going to discuss about these 6 timeouts, and as I'm going to start talking about this, you're going to start seeing time codes or the chapters, the YouTube chapters, where you can jump into the timeout that you're interested about, right? You don't have to watch the whole video, but I'm grateful if you do. How about we jump into the first timeout? Alright, guys, so the first timeout is called client header timeout. And when I say client, right, that means the client is responsible of this timeout, and most of the time, right, is the reason of this timeout. And when I say header, that means it's an HTTP request. So what we do is we're about to send an HTTP request. An HTTP request is a GET request, a POST request, a PUT, a delete, right? And the HTTP request it consists of different parts, right? So there is the header, there is the body, and there is other stuff too, right? That goes there. So the header goes with, like, I don't know, the content type and the cookies and other stuff. The body is the content, right? While GET request doesn't have body, you can still put on the URL, which goes into the parameters side. All right. So what we want to discuss here is when I establish a TCP connection between moi, the client, and Nginx as a proxy, and there are some back-end servers that we don't care about right now because most of the work that we're going to discuss is between those two, actually. When the client want to transfer, let's say, a GET request, right? It start building that GET request, right? It has a header, it doesn't have a body, to be honest, but sure, it has other information as well. So the first thing that I transfer is actually the header, right? And how do we transfer the header? It's a bunch of bytes, right? And when we transfer things into the TCP, these bytes become packets, right? Eventually. And each of the packet is sized as the MTU, the maximum transmission unit in the network, which I discussed in the OSI model and other videos as well, right? So the headers become 1, 2, and 3 packets, right? And here's what happened. So the client will say, okay, here's one packet, packet number 1, and that packet will have information that tells the Nginx that, hey, I'm about to transfer the header. And Nginx will start up a timer. It's called a header timer, which is that timeout, right? And once that timer runs, it starts running until the last packet for the header is transferred, Okay, so now that timer keep running, right? Let's say 1 second, 2 seconds. 1 second is a lot. So 1 millisecond, 2 millisecond, and then I start sending the second packet, right? And this packet gets acknowledged as well, correct, right? And then says, oh, this keeps, oh, there are more header content. Let's keep counting, right? And then I transfer packet number 3, and let's say something bad happened, and the server didn't acknowledge it, or the Nginx didn't acknowledge it, so we resend the packet number 3 because we didn't receive an acknowledgement, and this keeps going until 10, 20, whatever, right? And if all of these packets that belong to the header did not arrive in that amount of time, let's say this is I don't know, 60 seconds. That's a lot, by the way, guys, right? But if it doesn't reach with 60 seconds, the Nginx server will say, wait a second. It's been 60 seconds. It's been header's timeout, and I didn't complete that header yet, right? So, kill that connection. So the server will essentially just destroy the whole connection. And we're going to talk about what happens when you actually destroy the connection. All right. So that's the first timeout. Headers timeout, right? And this is very, very critical because these two parts, the headers and the body, are two distinct things. All right. How about we talk about the second one, guys? Awesome. So the second timeout is called the client body timeout, and you guessed it, same thing. I'm about to send a post request because you cannot send a body in the GET request, right? So I'm just about to send a post request, and it's a thick request, right? There is so much content in it. I'm uploading an image or a file, right? And same thing, we're doing a header, but this timeout is related to the body, and the body is usually large, guys, right? The body is always larger than the header. Well, it depends on the request. What do? We're gonna start breaking up the body into segments, right? And that's a lot of segments. 1, 2, 3, 4, 5, 6, 7, 8 segments, right? Or 8 packets. I keep saying segments, right? And here's how the timeout works. So that, as long as the header timeout didn't time out on us and the connection didn't close, we start transmitting what? The body, right? And packet number 1 will initialize and says, hey, Nginx, I'm about to send the body. And the Nginx starts another timeout called, body timeout. Okay, we'll start sending it. And here is the thing, guys. It starts counting, right? Okay, I sent you this, and I acknowledged number 1. And as you start counting the body timeout, that second, if you send another packet, that timeout gets reset. It's not for the whole body request, unlike the header. It's for each write operation. And that's the definition of the body timeout. So only if I kept resending the same packet over and over again, and it failed, and it took, I don't know, 60 seconds, right, for just one packet to arrive, and it didn't arrive, then at that time we close and destroy the TCP connection. So that's the client body timeout. And again, as you might have guessed, if you have a protocol other than HTTP, then that doesn't make any sense, obviously, right? It's only applicable for HTTP. Okay, if you're using WebSockets, that body timeout will only be applicable for the first GET request, which is an upgrade request, which is not really applicable also because we don't have a body in GET request. Awesome. So send timeout, the third timeout in Nginx. And the send timeout is actually not from the client to the server, it's the other way around. It's the server responding, right? So let's assume you started sending this header, sending the body, and the Nginx server started assembling all that and made sense of everything. And so, I now understand this request, and I'm gonna send a request to the appropriate backend server, get the response, and get back a result, right? And once I get the result, and I'm about to respond to the client, that's when this send timeout start kicking in. Let's say 60 seconds again, right? So here's what happens. I am about to start breaking up this request, right? And the whole packet will start becoming segment. Let's say just 3 segments or 3 packets. I keep saying segment, Jesus. All right, so 1, 2, 3. Okay, and now I sent packet number 1. and the client start acknowledging it. All right. The moment I send that packet number 1, I start a timer called send timeout timer, and that starts counting, right? And I send the first packet, and once I get an acknowledgement that this packet has been received and acknowledged, that timer gets reset and start to with 0 again, and you send other packet 2, and that timer gets started again, and then you receive an acknowledgement. So, and that's how the send timeout. So if you start, let's say packet number 3 for some reason kept failing, the client didn't acknowledge that for a long time, right? So kept sending, didn't acknowledge, send it again, didn't acknowledge, send it again, 3, and we're still in the same packet, right? For that write operation, that timeout reached 60 and then 61, and at that time, what does the server do? It kills the connection. And when the connection is died, there is another process that happens as a result. All right, guys, keep alive timeout. And this is a pretty straightforward one, right? So clients after HTTP 1.0.1.1 have the option to allow the connection to stay alive. And obviously you need persistent connection, otherwise you're wasting, you closing and opening these connections, right? So the keep alive timeout is a timeout after which an idle connection will be closed. So let's say you establish a connection and you start writing stuff to it, and then you stop. You didn't send any request, and each connection will have a timeout, right? A timer, and we'll start counting as long as it's idle, right? As long as it's idle, if there are no requests going to that connection, going through that connection, it will be destroyed after that, just to save on memory, right? Obviously, right? So the default, I believe, is 75 seconds on keep alive timeouts, right? And yeah, so that's essentially the keep alive timeout. Very simple. All right, lingering timeout. So the lingering timeout is one of those really interesting one when I read about it, and I tried to do a lot of research to actually understand what it means. To use the lingering timeout, there is an option called lingering, right? Whether you want to linger a connection or not. And what does that mean? That means if you close a connection, what does that mean? If I am closing a connection, whether it's a timeout or some other timeouts that close my connection, or the actual client closes my connection immediately, or the server got restarted. What does it mean to close a connection? There are two types. When that option, the lingering option, is off, that TCP connection is just dropped immediately. No time. Doesn't give you any chance when you do that. Immediately, whether their client is sending a request or not, it doesn't matter. The server will just die immediately. And that is bad, because if that HTTP client that is here, whether your C# application or a browser, if not handling closing connection gracefully, then it can get you into very bad situations, right? And you're violating the HTTP protocol by doing that. So what Nginx did, and I like that for them, actually, I like they did that, is that they introduced an option called on, and there's an option called always, right? I'm going to discuss just when that option is on and what does that mean, right? When that option is on, when you close a connection, that connection is not closed immediately. There is a timeout that starts. It's actually, that timeout is 5 seconds only, right? So that's 5 seconds when you attempt to close the connection, whether the client does, the server, another timeout causes the closing of the connection. The connection is not immediately closed. It waits for 5 seconds, right? And what does that do in that 5 seconds? It waits for client request. The moment the client sends anything, that request starts. That timeout got resets immediately, right? So starts at 0, and the client sends something while the connection is closed. That server doesn't actually respond. It just merely consumes the content and then discard it. Consume and discard, so that it doesn't leave stuff in the socket, right? Garbage in the socket. So it just cleans up think of it like a clogged pipe, right? So that 5 seconds is very, very critical. So the moment you close that connection, what will happen is that it waits. Okay, 1, 2, 3, 4. Oh, I got a request from the client. Reset. 1, 2, 3, 4. Oh, I got another request from the client. Not necessarily a request. It will not accept a new request. Let's be very critical about that, right? It will only start consuming the pieces of request, the complete request, right? So if a request has started, it will allow you to start sending all that stuff, right? But the moment that request is done, it will just reset that stuff, right? And finally, after like the 5 second is passed, it will destroy the connection, assuming there is nothing that has been sent between that moment, right? So that's the lingering timeout, and it's a very critical timeout in Nginx to keep things clean, to keep things from memory leaks and all this nasty stuff. And the final timeout, the resolver timeout, which is the DNS timeout, right? So if I am Nginx and I am about to make a DNS request, right? Really not really the client here, is just the Nginx server trying to make a DNS request, right, to some other server. How long do you want me to wait before that resolver just dies, right? So that timeout is not really important, but sometimes you want to know, you want to tweak that timeout so that if the DNS query is taking a long time, you want to look at those, right? And it's like maybe make them like shorter, and so they destroy later. Okay, all right, guys, that's it for me today. Quick video about Nginx and their timeouts. And have you noticed I haven't seen anything at that site? I might be missing some timeouts, but it doesn't look like it because I didn't look at any of that timeout that Nginx has, and I don't see anything at this upstream servers. Maybe, and that again, that's because of the bad doc. They don't tell you that, but these timeouts might not be applicable to the backend, right? Or maybe they are. I have no idea because the doc doesn't tell me anything, right? So you have to, I guess, experiment and see for yourself. All right, guys, check out the Nginx video, the practical video, if you want to learn more about how to deploy Nginx and all that stuff. And I'm going to see you in the next one. You guys stay awesome. Goodbye. What is going on, guys? My name is Hussein, and in this video I want to discuss Nginx backend timeout. So I made a video discussing all the timeouts that happen between the client and Nginx. So this is supposed to be Nginx, right? And yeah, now I want to make another video discussing all the timeouts that happen between Nginx and the backend server over here. How about we jump into it, guys? So as I speak, guys, you're gonna start seeing chapters, YouTube chapters, where you can jump into the interesting timeout that you want to learn about. So this is a new feature in YouTube that I absolutely love. How about we just jump into it? All right, timeout number 1, Proxy Connect timeout. And this timeout is specific when Nginx is attempting to establish a TCP connection to the upstream server or the backend servers, right? So what happened here is when Nginx starts, you define something on the upstream side for Nginx to load balance, right? So server 1, server 2, server 3. And when Nginx starts, it attempts to establish a TCP connection between each of these servers, right? And what it does, we know how TCP works. So there is a SYN, and there is a SYN ACK, and there is back and ACK, right? SYN ACK and then three-way handshake, and that will establish a TCP connection. If any of those actually didn't complete successfully in whatever this is, which is, I believe the default timeout is 60 seconds. If this didn't complete in 60 seconds, that will fail. That connection will essentially fail. We will no longer attempt to connect to this backend server, right? So sounds simple, right? So Proxy Connect timeout, right? So if you can, I would make this even lower, guys. 60 seconds is a lot. If I cannot connect to the backend server, which is supposed to be in the same network, by the way, in 60 seconds, that server is dead, right? And obviously this is applicable for all the servers here, obviously, right? So yeah, Proxy Connect timeout, pretty straightforward, huh? How about we jump into the second one? All right, the second timeout, which is proxy send timeout. It's another backend timeout, but this works when you actually have an established TCP connection with all these backend servers, right? The send timeout is the time it takes for Nginx to actually send a request, and not just a request, actually a packet, right, to the backend server, right? So let's say your client is making a GET request, right? And that GET request translates to how many TCP packets, maybe 2, right? And that eventually will be terminated. If TLS is necessary, TLS will be terminated and established at the backend, all that stuff. This is what we talked about, proxy connect timeout. But now, Nginx is supposed to send that GET request to the backend server, right? So I picked this based on the load balancing algorithm and says, okay, 1 and 2, I'm gonna send packet number 1, right? And if we didn't get an acknowledgement from the server in also 60 seconds, that's the default. If we don't get an acknowledgement for every single packet in 60 seconds, we terminate that TLS connection. We terminate that TCP connection, right? So that's the send timeout, right? And it's not for the whole request, it's for each packet. So if I get the acknowledgement, let's say in 59 seconds, that timeout is reset. Now if I send the other packet, I get to start from 0 again, right? Up to 60 seconds, right? So that's essentially the proxy send timeout, right? So again, if your proxy is taking more than 60 seconds, your server, your upstream server is taking more than 60 seconds, you want to check your Nginx logs and check those servers and maybe just drain them and remove them from your from your backend, right? Because they're killing your performance, right? And yeah, guys, this is, by the way, I'm sending a request. This is not receiving, the acknowledgement is not actually a response, guys, right? I'm just sending that request, right? And this is just an acknowledgement that I sent this packet. So technically the server here didn't even get that GET request to be actually process it. That's completely different thing, right? So we're gonna get to that, right? There is another timeout for the reading of the response. So we're gonna get to that in another timeout. How about we jump into this next timeout? All right, proxy read timeout, and this is the reading of a response. So you have already transmit the GET request from the client to the Nginx, and Nginx successfully sent that request to the server. Or the send timeout didn't actually time out. We managed to get it, and the server get this request and it start processing the request, and now it's about to send the response back to the server. So let's pick another color for response here so we don't get confused. How about yellow, right? So now the server is about to start sending the response, and let's say the response is 3 packets, right? It's an HTML page or it's a JSON, and it transformed to 3 TCP packets, because you know what, responses are big, right? And we need to chunk it up into different packets. So I said, packet number 1, send it, right? And now that Nginx will start reading that packet and it start a timeout. And I think it's also 60 seconds. I don't know what's with the 60-second timeout, to be honest here. So now we'll get that packet and it will send an acknowledgement. And now, so yeah, if now the server responded with another packet, right? And we acknowledge that packet, but we didn't get the next packet. We start starting the timeout, the read timeout, until if it's past 60 seconds and we didn't receive anything from the server, then we kill the connection and we move on, right? So that's a read timeout. So that's also, we gotta be careful with that, because again, it's not for the whole response, right? Even if the response is big, each packet shouldn't take that much time to be to transfer from the server, right? And we know that the server is actually about to transfer stuff to us, so we start that read timeout accordingly, right? So this is not for the whole response, it's for each read operation that happens from the server, right? And once we get all the 3 packets, I can look at it and say, oh, it's actually a beautiful JSON, and I can go ahead and send it back to the server, the client. All right, so that's the proxy read timeout. How about we jump into the next one? All right, that's another easy one, right? I have a connection here and to the upstream servers, right? And I didn't do anything. These connections are idle, are they just sitting there? The moment the connection becomes idle, that means there is no writes and there is no reads and there is nothing sent. There is no activity, right? We keep the connection again 60 seconds. If no activity happens in 60 seconds for this TCP connection, then we terminate it. And when we terminate, the connection, it goes through the phases, lingering and close timeout and time wait and all that stuff, right? Which we're gonna describe in another video. But yeah, keep alive timeout. If you wanna keep those connections more, knock yourself out. It's that's one of the timeout that I prefer to keep actually higher, because the establishment of a TCP connection on demand is expensive, right? Especially if the backend is actually H1, HTTP1, right? Because the request cannot be multiplexed, unlike H2. I don't even know if Nginx supports H2 on the backend, to be honest. I might be wrong there. Nginx experts correct me there. But yeah, if not, then that connection, if I'm sending a lot of requests from Nginx to the backend server, that connection will not be enough. So I'm going to establish multiple connections. And the moment I establish multiple connections, the three-way handshake takes a little bit of more time, and that a little bit kills your performance. Oh yeah, this one is one of my favorite, proxy next upstream time. And here's the thing, guys. All right. So remember when we said I am sending a GET request, right? And let's suppose that this is a stateless request, and I'm about to send it to this server. And the send timeout, which we talked about, timed out actually. I couldn't reach the server. I couldn't establish a connection with the server. The connect timeout or even the send timeout just dies. I cannot even connect to the server, right? So what the server will do is say, okay, I am going to start trying another server now, okay? I'm gonna try this server, okay? And if that server is also not responding, like the connect also timeout, like this server is not responding, I'm gonna try to the rest of the server. But how long do you keep doing that, right? You keep doing that for this amount of time, proxy next upstream time. So if you define that, I think the default is 0, which means that the Nginx will keep trying forever. And if this is done, it's gonna go back to all upstream. I think it's going to the loop as well. I might be wrong there. But if you have a lot of upstream server, the Nginx will keep trying all upstream server, which can kill your performance, because what's going on? The client is just waiting all this time, right? And your Nginx is not even connecting to the first server, so it's trying to the second server, and then the second server is also not responding, so it goes to the third server, and let's say the server 4 is actually responding. So if you set this timeout to be, I don't know, 10 seconds, then before we reach that, if the total amount is 10 seconds, then we will respond with the client to the client says, hey, okay, well, I don't know, there's a request not found, or not for I know, service not available, 500 probably an error, right? And yeah, so you can start messing with this timeout. And it's actually one of the interesting timeouts, and I don't know what you guys think. I would prefer this to keep this around the same time as the connect, right? If your connect is 60, which is, I still think it's a lot. 60 seconds is a lot, 1 minute, right? And I would keep that within the same range, right? 60 seconds. If I couldn't connect to the server 1, maybe try server 2. So I would make it maybe 120 seconds, right? To connect to the other servers. And I said, if I can connect in 120 seconds, just, yeah, don't even try, man. Yeah, so that's the idea. Proxy next upstream time. All right, guys, that was all the timeouts that I'd like to discuss in this video. It was a little bit of a short video, just going through all the timeout in the Nginx, at least the back end side. We have done this side. Now it's time to do this side. And let me know, guys, what other timeouts did I miss? And write it below in the comment section below. And I'm gonna see you in the next one. You guys stay awesome. Goodbye. We have talked a lot about Nginx in this channel. You know, Nginx is a web server, and it's also a proxy where you can make it into a reverse proxy, which acts like a load balancer, a caching layer, and it can also act like a normal proxy, which forwards requests on behalf of the client, and it also can act like a web server. I have my reservations about software that does two jobs, but nevertheless, Nginx is a great piece of software. It's a very popular, and we talked about a lot about this technology in this channel. I'm going to reference the course that we make on YouTube, where you want to learn from A to Z Nginx. However, all the videos that I made on this channel about Nginx were essentially installing Nginx physically on whether it's in Windows or Mac. I never made an Nginx video where I actually spin it up as a container, as a lightweight container. And this is what I'm going to do in this video. I'm going to show you how to do that. So in this video, I'm going to show you how to spin up an Nginx container and configure it to be a load balancer for two services that I have here. So first of all, I'm going to go to Chrome and show you that I have two services running on my machine here. Okay. And I'm using Node.js for those. I'm going to reference the video that I did for this. It's essentially a Node.js application that's listening on port 3333. And if you literally visit that, it's going to just return back, hey, the application ID is 3333. And there is another application running on port 2222. And the reason I do this all the time is just to notify the user which application it's accessing. So we're going to show the power of load balancing, right? So I have two applications. What I'm gonna do, I'm gonna spin up an Nginx container that acts like a load balancer to flip between those two services, right? Essentially as a layer 7 load balancer, okay? All right, how about we do that? So first of all, I'm gonna create a folder here called Nginx container, and the source code will be available for you guys. I'm not gonna write any code per se. It's just basically a Docker file and some configuration. So let's go into the container. So first of all, how about we write the actual configuration that we require, right? Before we worry about the actual spinning up of the container, right? So I'm going to use Vim to write an Nginx.conf file from scratch because I like to start always from scratch. All right, so we're going to configure Nginx to be a layer 7 load balancer to flip between, to balance these two services that I have. We're going to configure an HTTP context. And in this HTTP, we're going to listen on one server. And I'm going to pick, and on this server, I'm going to listen on port 8080. Okay. And we'll configure an upstream service called all here that essentially have two servers. The first server points to Hussein Mac on port 2222, as we showed, and the second one, port 3333. And Hussein Mac is basically my machine, right? So you can as simply use localhost, but you will not be able to run it on other machines in this case, right? So this could be the IP address as well. Once we do that, listening to that, the only thing we need to do is, since we're doing a layer 7 proxy, we will listen to the root / and if someone goes to that, I want to proxy pass anything to HTTP all. And for some reason, Nginx requires that you have a blank event here. So we're gonna do that because why not, right? So once you do that, we are ready to rock and roll. So let's go ahead and write that file. Okay, I'm gonna make this available. So the next step, which is the easiest part, is to actually write the Docker file so we can build an Nginx image so we can spin up our container. How about we do that? I'm gonna create a Docker file here. Obviously, if I can't type. And then this is the simplest part, where we're gonna pull the image from the official Nginx image. And the first thing we need to do is basically, before we spin up the container, we want to disregard whatever configuration that comes with this thing, and we're gonna copy our beautiful configuration instead. Okay, and the location for that is etc nginx.conf. So this will essentially be overwritten with our beautiful configuration that we have written. So we're gonna save that. The final step is to build the container. So we have Docker file, we have the config, right, which we will run, right? The next step is to build the container. Docker build -t, and I'm gonna call it Nginx app, because why not, right? -t basically names the image, and then dot, that means build whatever inside this current folder, and it's gonna look for a Docker file, right? So it's gonna build that stuff, and looks like there is an Nginx app image that we have built. Final step is to run the container. All right, time to run the container. In order to do that, we do docker run. You can optionally give the container a name, but I'm not going to do that. Do -p to map port 8080, which is running on the container, to port 8080, which is running on my host, which is Hussein Mac, right? This could be anything you want. This has to be 8080 because that's what we picked when we listened on the configuration, remember? And finally, you do Nginx app. And just like that, the application should start running anytime soon. All right. Now, if I go to my Chrome and I refresh this page, I am getting that I've been served with from the first application 2222. And if I refresh, obviously the next request that comes to the Nginx is gonna go to the next service, which is 3333, right? If I next refresh again, it's gonna go to back to 2222. And this is called round robin, and we talked about round robin. There are many load balancing algorithm that Nginx supports. All right, this is just one of them. Okay, so that have been Nginx on Docker. Hope you enjoyed this video. It was a quick and light video. I wanted to make this catalog of library of videos that for you guys, because you asked me, it's like, hey Hussein, you always install Nginx on your Mac, but show us how to do it on Docker. So there it is. I'm gonna create multiple videos like that, like for HA proxy and other stuff as well. If you enjoyed this video, give it a like if you like it. I'm gonna see you in the next one. You guys stay awesome.